Hello and welcome to another video of Grokking, the coding interview series. We are going through the sliding window pattern, and in this video we'll have a look at longest substrings with maximum k distinct characters. It has been classified as medium difficulty or intermediate if you have been solving problems on LeetCode. So let's quickly have a look at a few examples. Here we are provided a string and we are provided the maximum number of characters it can have, maximum number of distinct characters it can have, and we see that the longest substring in this case is ARAA. In this case the k is only 1, and the longest substring we can have in this case is AA. In the third example we can have 2 such strings, and in the fourth example we can have just 1 such string. So and essentially, because the k is 10 here, so we end up returning the entire string because the number of distinct characters within the string is less than k. So again, we stick to our processes which we have been using for sliding window. We know we have to iterate through the array only once. We know there will be a condition clause. The only addition I think in this implementation will be we'll have to somehow keep a track of frequency of the current, or frequency of the characters in the current window. So let's start with an implementation, and I'll explain as we move deeper into the implementation. So first we'll have like hash map, which will be the window frequency. We have max len, we have window start, and if you have been observing the previous implementation, this is pretty standard. Like, this is how we go ahead and initialize things, and you know that the second step will be to go ahead and iterate through the window end. And instead of array, as we saw in the previous examples, it will simply be a string. Now at this stage, what we want to do is we want to, so if this element isn't already in this window frequency hash map, we would want to add it. If it is already there, then we want to increase it by 1. So if else we simply initialize it to 1. So this way we can keep a track of frequencies of all the characters which have been included in the window. And at this point we also want to check if the length of the window fric is more than k, which would mean that the number of distinct characters within the window is more than k, which we cannot allow. If this is the case, then we would want to string the window until and this would be indicated by the while loop, until the number of distinct characters in window is less than k. So how can we go about doing that? And again, a very standard process. Like, as the first step, we want to see if the max len is what we are expecting. This will be window end minus window start plus 1. So we have the max len sorted out at this point. we want to reduce the frequency of that element within the hash map. In this case, the max len would actually be outside. Okay, this will be after we have actually removed all the elements. So essentially what we want to do at this point is, if here we want to have window start instead, if it is 1, we can simply remove it from the hash map. Else we just reduce it by 1. And we want to increase the window start. And at this point we want to calculate, after we have removed all those elements, we want to calculate the max len. And window end, window start, and we simply want to go ahead and return max len at this point. Let's quickly do a walkthrough and see if it is in line with what we are expecting. We have the initializations, we iterate through the string. We add the frequency of the character, which is indexed by window end into the string here. So if this character already exists in window fric hash map, we just increase it by 1, increment it by 1. If it is not there, then we initialize it to 1. And at this point we want to make sure that the number of distinct characters within our window is less than k. So until it is less than k, we keep shrinking the window. And the way we do it is, if the frequency of the character, which is shown by window start, is equals to 1, we just remove it from the hash map. If it's greater than 1, then we just decrease it by 1, and we increase the window start. And this should give us the answer that you're looking for. Let's run it and see in case there are any errors. Yeah, so seems like our implementation is working fine. Let's have a look at the runtime complexity, runtime and space complexity for the implementation. When it comes to the time complexity, we are going through the string once, and we also have this inner loop. So the worst case, it can be n plus n, which would be O of n. So the time complexity will be O of n, and we have a hash map which we are maintaining throughout the process. So the worst case scenario in this case, which I believe should be O of n as well, but again, let's do confirmation and see if this is the case. It's actually O of k, maximum, storing a maximum of k plus 1 characters. Oh yes, so we wouldn't be storing the characters of the entire string, but only k characters at a moment. Okay, so this makes sense. So a slight correction here, it wouldn't be O of n but O of k, and here indeed the time complexity is O of n. I hope you enjoyed the explanation. Please let me know if in case I can improve anywhere. And until the next video, have a great day.